Hello, my name is Eduardo Suarez. In this video, I'm going to show you how to configure and extend an axis in RoboGuide. There is an excellent video from Adam William on YouTube that explains how to configure a 7th axis on a rail. In this video, I'm going to do a similar configuration, but in a slightly different way. We're going to start by creating a new project on RoboGuide. We're going to start from scratch. So if we're going to create a new cell, we just can select new cell from this screen, or we can go to the file on the menu and select new cell, or select view and navigator. When we open the process navigator, we just select start a new cell. And the wizard is going to pop up. On the wizard, because we started from RoboGuide, I'm going to select the 100 Pro. I'm going to select next. It's going to show the name, but default is showing 100 Pro 1. We're going to go with that. Select next. Here, from these options, we are going to select create a new robot with the default 100 Pro configuration. We select next. In here, I have the versions already installed for RoboGuide 9.4 and 9.3. I'm going to select the version 9.3. I select next. On this option is asking for the enogram tooling. I'm not going to select any enogram tooling for the moment. I select next. And on this screen, I'm going to select the default is the robot R2000 IC 165F. I select next. On this screen is asking for the motion groups. I'm not going to do any selection. I just press next. And in here, we're going to select the options. So for looking at the options, we can just click on the search field and type the options that we want. I'm going to type constant path, and I'm going to select the option R663. And next, we are going to select extended axis control. That is option J518. We press next. Here is showing a summary of the configuration, and we just press finished. What's going to happen next? RoboGuide is going to start creating the configuration for the work cell. This is going to take some time, so for the moment, what I'm going to do, I'm going to pause the video, and I'm going to come back when it's asking for the next option. Okay, here RoboGuide is asking for the flange type. What I'm going to do, we can close this pop-up window that is showing here, and we're going to go with option number 1, that is standard flange. Select 1 and press enter. And I'm going to pause the video again until the work cell is finished. At this point, RoboGuide has finished creating the configuration for the work cell. We have the robot in the work cell, and to summarize what we have done so far, we just created a new work cell from scratch, and we added the options for the constant path and for the extended axis control. What we need to do next is to configure the extended axis. We're going to select robot from the menu bar, and from the drop-down menu, we're going to select the start controller and control start. Notice that the teach pendant is going to pop up. And from here, we're going to select menu and option number 9, that is maintenance. You're going to notice in here that on the right of the robot is showing 0, meaning that the extended access hasn't been configured yet. We're going to select the extended access control by pressing the down arrow key, and we're going to press F4 for manual configuration. We're going to select option number 1 for group 1, enter. Here we're going to, by default, is showing the axis number 7, so we're going to select axis number 7 for the extended axis, enter. Here we're going to select option number 2, is add extended axis, and here it's asking how many axes we're going to add. We're going to select 1 and enter. Here we're going to select option number 2, enhanced method. Here we're going to select for motor size, option number 64, enter. Motor type is going to be option number 2, enter. Here we're going to select option number 1, integrated rail, linear axis, enter. Here we're going to select option number 1 for the direction on the x-axis, enter. Ear ratio, we're going to select 120, enter. The maximum joint speed, we're going to select option number 2, no changes, enter. The motor direction, we're going to select option number 2, false, enter. The upper limit, we're going to select 5,000, enter. For the lower limit, we're going to select minus 5,000, enter. The master position, we're going to select number 0, enter. Acceleration, deceleration time, for the acceleration time 1, we're going to select option number 2, no change, enter. For the acceleration time 2, we're going to select again option number 2, no change, enter. For the default minimum acceleration, we're going to select option number 2, no change. Low ratio, we're going to select 2, enter. For the amplifier number, we're going to select 2, enter. For the amplifier type, we're going to select option number 2, enter. For the brake number, we're going to select 1, enter. And the servo timeout, we're going to select option number 2, disable, enter. So with this, we have completed the configuration of the extended access. We're going to select option number 4 to exit. And now we're going to select option number 0 to exit the settings. You're going to notice now that on the right, where we had before 0, now it's showing 1, meaning that the extended access has been configured. Now we can select the function key, and we're going to go with option number 1, that is called start, enter. We're back on the work cell. I'm going to save the changes. And notice that even though we have configured the extended axis, nothing has changed in the work cell. That's because we haven't defined yet any machine that uses extended access. So the next step is going to be adding a machine. We're going to select machines from the tree, right click, we're going to select add machine, and we're going to select box. Notice that it's adding a box on top of the robot, and at the same time there is a property window for the machine. By default, the name is machine 1. We're going to change that to rail. I'm going to apply, and I'm going to change the size of the box. For the X, I'm going to change it to 10,000 millimeters. For the Y, I'm going to change it to 750 millimeters. And for the Z, I'm going to change it to 300 millimeters. I'm going to apply the changes, and notice now that the rail has changed in size. And the other thing I'm going to do, I'm going to move it to 300 millimeters in the Z direction. When I apply the changes, you can see now that the rail has moved to the floor, but still the robot is overlapping the rail. I'm not going to make any changes yet for that. What I'm going to do, I'm going to change the opacity for the rail, and I'm going to apply the changes, and I'm going to close this window for now. What we need to do next is going to select the rail, right click, and attach the robot. When we select attach robot, the only option that we have is the only robot that we have on the controller that is in group 1. We're going to select this robot. And notice now that the robot has moved on top of the rail, and we have a new pop-up window for the link. At the same time, the link is showing as a child of the rail with a representation with a servo motor as an icon. From here, we are going to select General, and you can see that the servo motor is showing underneath the rail. If you cannot see it, you need to change the opacity for the rail. And the orientation of the servo is on the Z direction. We're going to change that by going back to the properties for the link. I'm going to select the General tab, and on this option for the Z axis, I'm going to change it to the X axis, and I'm going to apply the changes. So now the servo has moved from the Z axis to the X axis orientation. I'm going to select the motion tab, and you can see that here we have a servo motor controlled, and for the access information on group, we have group 1, and for the join is the join number 7. The current position right now is showing the robot on the center of the rail, and we can use this sliding bar to jog the robot. So if I move the sliding bar to the right, I'm jogging the positive direction, and if I move the sliding bar to the left, I'm jogging in the minus direction. I can go to minus 5,000, or I can go to plus 5,000. When I close this window, we're going to save the changes. And now I can show you one more thing. If we open the teach pendant, I can jog the robot from the teach pendant. We're going to select Shift, and I'm going to change the speed from 100% to 50%, and I'm going to press the J7 plus, and the robot is going to move in the positive direction on the rail. And if I press the minus J7, it's going to move in the negative direction. Notice here that I'm using joint for jogging. If I select group and I change that to group 1 is join, S is the meaning for the supplementary axis. Now I can jog it again, but this time what I'm going to use is the supplementary axis number 1 for join number 7. So if I press J1 in the positive direction, and still jogging again forward, and if I jog it in the minus G1, I'm moving in the reverse direction. So a group can have up to 9 axes. And you can see here that we have only keys for J1 up to J8. So if you have an axis number 9, you can wonder how I'm going to jog it in the axis number 9. Well, the answer is you have to be in this group G1S joined, and now you're going to jog the axis number 9 using the key for J3 plus and minus. Last but not least, we're going to create a simulation program. There are a few ways we can do that. We can expand the robot controller, and here on programs, select right-click and add a simulation program. Another option is select view from the menu bar and open the process navigator. From the process navigator, we select teach programs and add a simulation program. There is still another option. We can select teach from the menu bar and select add a simulation program. By default, it's going to call program 1. We select OK. And the program is going to be added on the tree. At the same time, it opens the simulation program editor. And you can notice here, if we select the teach tool, the triad is going to show on the enogram tooling, and at the same time, the position of the robot with the coordinates it shows on the bottom line. We're going to select joint, and we're going to move the robot on E1. It's going to be the extended axis. We're going to put it in position 0. We're going to record this position. You're going to notice that we're going to make a linear move at 2000 millimeters per second, and fine. Now we're going to change this one to Cartesian, and I'm going to move the x-axis 500 millimeters. I'm going to record this position, and we're going to create more movements. We're going to move the extended axis 500 millimeters. I'm going to record the position. We're going to move the x-axis another 500 millimeters. I'm going to record the position, and we're going to keep doing that. So I'm going to move again 500 millimeters, and we're going to do that a couple of more times. Another 500 millimeters on the X, and another 500 millimeters on the J7. We're going to save, and now we can run the simulation. We're going to notice that the robot is going back to the origin and start moving forward. One more time. Now we're going to create another simulation program, and this time we're going to use position registers. Start by putting the robot in position 0 again. We're going to select joint, and I'm going to move it to position 0 on the extended axis. We're going to open the teach pendant, and we're going to go to the position registers. We're going to select position register 1. We're going to clear the data. And we're going to go again to position, and I'm going to put the data to 0. Notice now that we have a button for a page. On here, if we select page, we go to the second page, and this is going to be 0 for the extended axis, and we're going to press done. Now we go back to the simulation editor, and we're going to start adding instructions. You notice here, if I select instructions, there is a drop-down list with all the instructions that we can add in the simulation. If we want to add any instruction that is part of the teach pendant but is not in the list, the way that we do that, we select the remark, and besides the exclamation mark, we add a question mark. Now we're going to select position register 1, element 1. We're going to initialize the data to 0, and we're going to do the same for the element 7. Position register 1, element 7 equal to 0. We're going to add a remark, and we're going to record the position. Now we are going to add a for loop. We're going to go from 1 to 5. I'm going to close the for loop, and here we're going to add a new instruction that is going to be an increment for the position register. Position register 1, element 1 equal to position register 1, element 1 plus 500 millimeters. We're going to record the position, and this time I'm going to add an offset for the position register 1. Now we need to do the same for the position register element 7. Position register 1, element 7 equal to position register 1, element 7 plus 500 millimeters, and we're going to record the position again, and we're going to add the offset for the position register 1. Now we can simulate. We can run the simulation and see what happens. you notice that the robot starts moving using the position registers and the for loop. We do that again. You're going to see that if we go back to the teach pendant, we press the select button. We're going to do that here, select the button, and we open the program number 2. We can see all the instructions that we added on the simulation program. Just to summarize, we have created a program from scratch. We added a selection for constant path and extended axis. We configured the extended axis. We added a machine, and we added a link to the robot. And finally, we created a couple of simulation programs to test the movement of the robot. I hope you find this video useful, and please leave your comments below.